Hi everyone, back with another update. I posted a reply on the RBF thread earlier this week, and I was hoping actually to have posted this update sooner. However, I ran into some difficulties with finishing up the voltage meter. I thought I had it working perfectly, but some further testing turned out to be, prove me wrong. The reason I started working on this I thought about this a few months ago when I was more actively working on the hardware, and that is that the current charger in the disk only has a charging LED and a done charging LED. I know the chip that they're using on the charging board, there are more extensive versions of it that have also battery measurement, and they can indicate low battery voltage, but this one doesn't have that. So I thought, okay, I'll implement a voltage divider and hook it up to the Arduino, and yeah, if then the voltage gets too low, I'll have it turn on the red LED. So that was already in my mind. Recently I got a comment from PropMaster 2000 on the RPF thread, and he came with the same thing, and he was worried about the LiPo batteries from, hey, you're afraid you're charging them too, you'll discharge them too low, you might damage them. At that point I did forget about the fact that I bought protected batteries, so my LiPos have protection circuitry, which means and if they get to 3 volts they cut off, and they can't, there's overcurrent protection, so it can't draw too much current, and there's over voltage protection, so I can't draw too much voltage. So and the charging circuit from the LiPo charger it prevents overcharging, so I'm safe at those points. I did at that point continue on working. Okay, I want those LEDs working, so uh, I'll work on a voltage meter. I got that work up and running pretty quickly and posted a update about that on my Instagram at that time. Um, Unfortunately, later on, when I connected it to my power supply, whereas I'm measuring connected to my computer, my multimeter is saying 3.74. On screen it's saying 3.74, so we're nice and bang on. Connecting it to my power supply, then it did not work. And I think my problem is, and I'll go over that again in the code in a moment, I am measuring the same voltage that the Arduino is powered from. And I read up on that with some Google searches, and okay, if you use the internal reference voltage of the Arduino, you can kind of work around that, because then you're using the reference voltage that the Arduino creates from the voltage it powers from, and that's a volt in this case. And then you have a different sort of reference to measure from, and then you can do it. I think with the multiplier that I have to use later on, I think that's what's messing me up. So I'll just go to the code and you'll be able to see that. So from the beginning off, so I use these guys as sketches that I found with some Google searches as reference, and built upon that and added things to change things to get where I need it. I believe this one is based on Wawa sketch, and yeah, I did change it. The original one had a 150k resistor and a 10k. I changed it to two 10ks because I'm not measuring higher voltages. It's just a few volts. So halving it with two 10ks, I have a one. It just halves it in this case. Um, that's fine. Moving down, I just defined the LEDs. This for the input pin for the voltage divider and the low battery LED. I had this in here earlier, but when I remembered I don't need a power cutoff using the kill pin option I have on that push button, I'm going to leave it out in eventual usage of this test code. So I'll just keep this. But it is possible you can use it for something else. But I'm not going to be needing this, since yeah, the batteries have their own internal cutoff voltage. So when I really push it too far, the batteries will just cut the power. So not going to be needing this with protected batteries. Moving on, these are the definitions. The variables used to store values during calculation and the final voltage, and the reference that is used to um, uh, multiply the value measured on the voltage divider to the actual value back, and then convert it further to volts. And I think this is my problem with it not working correctly when I disconnect it. I think what's happening is when it's plugged into USB, the USB power is getting in the mix. I still have to figure this out, but I thought, well, let's just post this because I'm going to be messing around with a few things more later. The low voltage here is what I used later on, and a bit I added to turn on the red LED. It's indicating a low voltage, which of course now isn't working unless I have it hooked up to my computer. Then you have the setup code, which just sets the pin. The analog input pin is an input, the low battery LED is of course an output, and this one is not used because, as I said, it's not used. This is the bit that should have helped me, I believe, at first, but I think I have to tweak a few things to get it right. And this is the internal reference set, so I can use this to set the internal reference voltage. I mistakenly left this to internal, but this should be 1v1 because that's what's used on other boards. No, I could use internal work fine, yeah, on my Leonardo, which is also an M0, but when I moved to the feathers, I found, after reading up, I have to use this complicated looking command to set the ADC to 1.1 volts or 1 volt as an internal reference, which is then makes it of course possible to measure it while it's connected to the battery. Moving to the rest of the code. So if you're using this with a difference with the Arduino connected to a other voltage source than the battery, then you don't need the internal reference. And I believe this would be 3.3 on Arduino board, on 3.3 Arduinos, and 5 on 5-volt Arduinos, depending on your source voltage. So what this does then, the actual measuring code is only these few lines. So you read the analog input, which is of course a 5 in my case, connected to the voltage divider. Then since I have a voltage divider that halves it, I have a 1/2 voltage divider. I'm not sure how to say that, but I have to measure it twice. In the original sketch, it was a 1/16 voltage divider, 10k and 150k resistor, so they measured 16 times, but in my case, two 10ks are more than enough. So then to get to the value I need for the rest of the calculations, it goes through this line. It does this line twice because I set it to 2 times here. So it takes total, and so this value gets added with the analog read, and then the second time total, analog read, and that's the total value in total here will be the amount of times that value has been read. So say it's measuring 0.3, it does it twice, so the value in there will be 0.6. And then to calculate V out, it takes V out, and it takes the V out will be total times the reference set here. So say it was measuring 0.3 on the voltage divider, it has 0.6 in here, it'll take the 0.6 times the 1.980, and then it's divided by 1024 to convert the readings to volts. And then as a last bit, this was 3 separate lines, but I set it to 1. I learned this from when I was studying up another codes. You can do it in 1 line. So the first bit here is the battery voltage is, colon, space, and then I print the V out. When you do it in one line, you do have to encase it in a string, so string colon V out bracket, V out bracket, and then it ends up printing V out. If you just set V out here, it gives an error, and then another plus, and you just add space fold, and that's that. And then it resets total to 0, so it can do the measurement again for the next run. So in my case, I then continued on with adding the code required to turn my low battery LED on and off. To do that, I use an if statement. So if V out is greater than or equal to low voltage, which is the voltage set here, in this case 3.2, then the low battery's LED stays off because it's not low. Else, so if it's lower than low voltage, then it is of course low, and then it digital writes the low bat LED to high, turning the red LED on, and I also added a serial message indicating low battery voltage. And that's all there is to this. And if the critical voltage is implemented, then this code would be used, but I'm going to take this code out, and of course the reference here and here and here, because I'm not going to be using that. Since there is a discrepancy between what I'm seeing on my screen and what happens when it's connected to my lab bench power supply, simulating a voltage battery so that I can manually turn the voltage down, it doesn't work correctly. So I do think the problem what I'm having is with the reference that I'm setting. So to counter this, I could connect a separate LCD. I don't have one yet, it's in the mail, so that I can look at this one without the USB connection there, so that I can figure out, okay, what's happening. I use the other M0, so I have this one measure, and I can use the other one I have in my disk here to read from. That's what I'm going to do. So I got this JST connector, which I was planning on getting. It's a 5-pin, so it takes my ground, TX and RX pins, and it will also be taking my NeoPixel pins, because I'm also going to be connecting those later to this one and adding it in the disk, so that the music maker operation does not mess with the animation, because I noticed that when the music maker is not being used, the animations run much faster, so that's also to come. So what I'm planning on doing is have the output from this one sent via serial communication to the other one, and reading it there and seeing if I see a difference when the measuring Arduino is not hooked up to a computer, and from there determine what the actual reference setting should be up here, and if it's indeed being messed with when it's hooked up to my computer. So that's to come. So for now I uploaded this battery monitoring sketch to my GitHub page, so that people can use it, and if there are there's anyone who can tell me what I'm doing wrong, if they're looking at this and going, oh my god, you're doing that wrong, please tell me. I'd love to hear. That would help me a lot to of course learn and improve. If I figure it out myself before that, of course I'll be posting another update about that. But for now I'm going to leave this for a moment, because it's not critical to getting the disk finished. So this might be revisited at a later date, because I want to get the animation stuff working better. So for that I'm going to do another video after this one about serial communication, and also go into the plans I have to change the disk further. So have a good one. If you like the video, please like it, and subscribe if you want to see more of this of these videos and be informed when they come out. I also have a Twitter and Instagram where I post updates more regularly, just little snippets if it's relevant. So have a good one, and the next video will be coming up soon. Have a good one.